Hello. I am sorry I'm not here. I'm at a doctor's appointment, but I made this video for you, so hopefully you can keep apprised of what we're doing. Please get out your paper, start working on the warm-up. All right, you should be already doing that. And keep working on that. I'm going to give you a few announcements. The first announcement is that, for obvious reasons, I do not have tutoring this afternoon. So please come Wednesday or Thursday. I will have both morning and afternoons open. So please come to do that, especially if you need to make up any work. I know that report cards went out yesterday, and a lot of you still have eyes, so please, please, please come as soon as you can. Make up the work, get it done, all right, as soon as you can. So please come to my tutoring Wednesday, Thursday. All right, last week if you must, but better to come ASAP. The test for Unit 11, right, we're at 11.3 today. The test for Unit 11 will be April 28th, which is a week from this coming Friday. All right, so a week from this coming Friday. So you have about 10 days or so. So make sure that you are aware of that, all right, and keep apprised of what's going on. Today we will be doing the warm-up and then doing some notes, and then you will have hopefully a little time at the end to work on some homework. All right, be nice to the sub. I expect you to be doing this. All right, so at this moment, please pause the video, allow the kids to work on the warm-up a few more minutes, and then when they indicate that they are ready, you can press play again. Alright, so on the warm-up, alright, so the first problem we want to do is 4 to the x plus 2 equals 8. Alright, sorry I had to cross out the exponent. So in this problem, what we're going to do is we're going to use the same base. Now, neither 4 nor 8 have an exponent that will help us get the other one. Alright, with no exponent of 4, we'll get 8. So we have to try to find a smaller base that we can use. Now the base that we're going to be using is 2. 2 is the base. So what I can do is I can rewrite the 4, right, as 2 squared, keeping the exponent x plus 2, and that will be equal to 8. Right? But I can also rewrite the 8. So I'll have 2 squared to the x plus 2 equal to 2 cubed. Alright, once I have this, the properties of exponents say that I can multiply these together. So the 2 and the x plus 2 I can multiply. When I distribute, alright, 2 times x gives me 2x plus 2 times 2 is 4. And that's going to equal 2 cubed. I have the same base of 2. Right? So all I need to do, and I'm going to do that over here, is bring down my exponents, so I have 2x plus 4 equals 3. Now I just solve for x. So I just subtract the 4, subtract the 4. So I have 2x equals negative 1. Divide by 2, both sides. X equals negative 1/2. Alright? So using the same base, alright, this case we had to solve for 2 instead of, or use the base of 2 instead of 4 or 8. Alright, many times you'll have to do that. Alright, so number 2, alright, natural log of x minus the natural log of 4 equals 2. In this case, right, we're going to have to use a property because, if you remember, we cannot solve unless we have a single log on that side. So we need to combine these two logs. Alright, hopefully if you remember, when we have the subtraction of two logs, right, we can rewrite the log, right, so natural log, and subtraction means we divide. Alright, subtraction means that we divide. So we have the natural log of x divided by 4 equals 2. Now we have a normal logarithmic equation that we need to solve. So first we find out the base. So the base of natural log is e. Alright, so base e, always. So we write a nice big E, and both sides of the equations then become exponents. So natural log of x over 4 equals e, and 2 becomes the exponent on that side. Now e to the natural log. Alright, that's the whole point of using this property. Alright, because that cancels, leaving just x equals 4, and that equals e squared. In order to solve for x, times 4 times 4, so x equals 4e squared. Alright, and then you can find the decimal approximation if you wish. Alright, so, number 3. Okay, so number 3, sorry. Log base 6 of 4 plus log base 6 of x equals 2. Alright, so again, we have to use another property. Alright, so we need to use another property. When I have, right, 2 logs here, right, added together, right, I can rewrite it, right, so log base 6, and multiply what's inside, so the 4 and the x. And that's going to be equal to 2. Right, so now I have a log equation, so I need to change it to exponential. My base is 6. So I'm going to write a nice big 6, and this becomes my exponent. So log base 6 of 4x, and then again, 6 is my base, 2 is my exponent. Right, so 6 to the log base 6 cancels out, leaving me just 4x. 6 squared is 36. Divide by 4, x is going to be equal to 9. Alright, so the actual number 4, 2 log of x equals 2. Well, the easiest thing is probably just to divide by 2. Alright, so that gives me log of x equals 1. Alright, not too difficult. Now, does anyone remember the invisible base that we have with this? Well, hopefully you said the base is 10. Alright, base is always 10 if it's not written in. Alright, so base 10. So, we have a log to change to an exponential. So I use 10 as the base. And the log becomes my exponent, and then 10 to the 1. 10 to log base 10 gives me x, and that is going to be equal to 10. Alright, so hopefully you have your warm-up. Alright, take a few minutes if you need to copy this down. Alright, so for the sub, if you will please hand out the 11-3 notes to all the kids, and press play when you are done. Alright, so this is going to be the last part of the solving notes that we're going to be doing. Alright, we've learned several ways of solving. Right, so what we're going to do first is we're going to review some of these methods using some problems that are a little even more in-depth, more, I don't know if they're difficult, but more complicated than what we've dealt with in the past. Alright, just to make sure that we absolutely know what's going on. Alright, so let's just work on some of these problems. and then we'll start thinking about some of the problems that we're going to be using next class when we start word problems. Alright, so number 1, let me zoom in here. Alright. There we go. Alright, so number 1, we have 4 to the x plus 1 equals 8 to the 2x plus 3. Now this is very similar to the first one we had on the warm-up. Right? Again, there are no exponents of 4 or 8 that will equal the other number. So no exponents of 4 equal 8, no exponents of 8 equal 4. So again, we have to use a smaller base, and the base we want to use is 2. So like we did in the warm-up, I want to rewrite this 4 as 2 squared. And then put the exponent on the outside. We want to rewrite the 8 as 2 cubed. And then put the exponent on the outside. Alright, so properties of exponents. I say that I multiply, right, which in our case means distributing. Alright, so I'm going to have 2 times x, 2x, plus 2 times 1 is 2. That's going to be equal to, also base 2, 3 times 2x, 6x, plus 3 times 3 is 9. Alright, so now I have a base of 2, the same base of 2 on both sides, so I just bring down my exponents. So I have 2x plus 2 equals 6x plus 9. So now all I need to do is solve for x. So first I subtract the 2x. So I have 2 equals 4x plus 9. And go up here. So next I want to do is subtract the 9. So I get negative 7 is equal to 4x. Divide by 4. So x equals negative 7 over 4. You can put a decimal if you like, but most of the time just write the fraction. Alright, so anytime you get a relatively easy fraction or just the number, write that. Decimal approximation only if you have e or something that's very weird, right? And we'll talk about that in just a minute. Alright, so this is how you use the same base formula. Right, one of the very first things we used. Alright, so number 2. Alright, so I have negative 10 equals log base 3 of x plus 3 equals negative 10. Alright, so if you remember, right, always we want to take our logarithmic expression and we want to isolate it. Alright, so we need to isolate that. So we need to move this negative 10. Since it's added, we just need to move it over by, in this case, adding 10 to both sides. Alright, so that gives me log base 3 of x plus 3, now an isolated expression, equal to negative 10 plus 10 is 0. Now I have a log expression, so I need to change it to exponential expression in order to solve. So I first find my base. Alright, my base is 3. So I write a nice big 3 with the log expression as my exponent. So I have 3 to the log base 3 of x plus 3, and then that equals 3 to the 0. Alright, so 3 to the log base 3 cancels out, leaving me just x plus 3. And 3 to the 0 is what? Well, I hope you said 1, because anything to the 0 power is 1, always and forever and ever and ever. No exceptions, alright? So always 1. And then I just want to subtract 3, right? So x equals negative 2. Right? So that one, not so hard, but just keeping in mind, isolate. If you have 0, you get 1. Alright? So moving on to number 3. So number 3, we have 11 to the n minus 8. Blow this up just a little bit more. Minus 5 equals 54. So again, like before, right, we want to isolate that expression. We want to keep the base and the exponent. We want to get those by themselves. So we need to move this 5. So we'll just add 5 to the other side. So I get 11 to the n minus 8 equals 54 plus 5 is 59. Now when I have a logarithmic expression, or an exponential expression, excuse me, when I have an exponential expression, I need to change it to a log expression. And the way that I do that is first identifying the base. In this case, it's 11. Then what I want to do is I want to take the log of both sides of that using that base. So for this, I take log base 11 of 11 to the n minus 8 equals log base 11 of 59. Right, so the property of exponents tells me that I can cancel this out, right, leaving me with n minus 8 equaling log base 11 of 59. To solve for n, I add 8. So I have n equals log base 11 of 59 plus 8. Now in this case, you definitely do want to use your calculator. Alright, so if you don't remember how to use it when you have a base that's something like 11 instead of something else. Alright, so on your calculator, alright, you want to go to Math, just right below the alpha button. Scroll all the way down until you see log base. Alright, that's letter A, so you want to go to log base. Press enter. Alright, so I have log base 11 of 59, so I put in 11, 59, and then plus 8, enter. So I get 9.700, and then the 4 means like round down. Alright, so n equals 9.700. And do keep the zeros there. You're gonna need, they actually need to be there. Alright, because it doesn't stop at 9.7. Alright, so that's how we use the calculator. Alright. Number 4, log of x plus log of 2 equals 1. This is very similar to the problem we had again on the warm-up. Right? So we have 2 logs. Alright, we have 2 logs that I need to combine into a single log. When I have addition, alright, this becomes a single log, so log, and then I multiply x and 2. So I'm going to write that as 2x equals 1. And just like again we had in the warm-up, my invisible base is, hopefully you said 10. Alright, so this is going to be base 10. Base 10. Very, very important. Alright, so if I have a log expression, alright, so I have 10. The log becomes my exponent. And then I have 10 to the 1 on the right hand side. Alright, 10 to the log, base 10, gives me 2x on this side, equal to 10. Divide by 2, divide by 2, x is equal to 5. A relatively simple problem. Alright, not too difficult. Alright, so number 5. we have log base 6 of 5x squared minus 29 is equal to 3. Alright, so first I ask myself, is it isolated? Yes, it is. I don't have anything either added or subtracted, anything multiplied. All I've got is my log expression and what's inside the parentheses. Alright, so I can immediately change it to log form. Identify the base. In this case, the base is 6. Right? So I want to have 6 and then use this as my exponent. So log base 6 of 5x squared minus 29 equals 6 again is my base, with 3 is my exponent. Alright, so 6 to the log base 6 cancels out. So I have 5x squared minus 29. 6 cubed is 216. Right? So add 29. So I have 5x squared equals 216 plus 29, 245. Divide by 5. Always in my quest to solve for x. Alright, so I have x squared equal to 49. Alright, in order to solve, what I want to do is take the square root. So I take the square root of both sides. So I'm going to have x equals, and 7 is what I get. But when I take the square root, plus or minus 7. Alright, plus or minus 7. Alright, so make sure that you include both. If you take the square root, you must include both plus and minus 7. Alright, so just be aware of that and be very sure that you are comfortable doing that. Alright, and you don't forget it. Alright, so this case we get two different answers. Alright, so keeping on a review, alright, so we have 3.4 e to the 2 minus 2x minus 9 equals negative 4. Alright, bunch of stuff going on in this problem. So first I need to think about, if I need to isolate this, which is definitely what I need to do, what is the base so I know where my exponential expression is? Well, in this case the base is e. Alright, so this is base e. Alright, so I need to move not only the 9, but also that 3.4. But I'm going to move the 9 first. I'm going to add 9. So I get 3.4 times e to the 2 minus 2x equals 5. Alright, now I need to divide by 3.4. So I'm going to get e to the 2 minus 2x equals 5 over 3.4. Because that's a pretty not so nice decimal, I'm just going to keep it in fraction form, at least for now, and then we'll worry about decimals later on. Alright, so I have e, that is my base, which we established at the beginning. So I need, when I take the log of both sides, the log that is base e is natural log. So I need to take the natural log of both sides. So the natural log of both sides. Right? The natural log of e, that cancels out, leaving me just 2 minus 2x. That equals the natural log of 5 over 3.4. Now I just need to solve for x. First thing I do, subtract 2. Alright, go up here. So I have negative 2x equals the natural log, move that over just a bit, of 5 over 3.4 minus 2. Alright, so now I just need to divide by negative 2. So I get x equals the natural log of 5 divided by 3.4 minus 2 divided by negative 2. Now I highly advise, if you put this in a calculator, because there's a lot of stuff going on, is first do the top. Alright, do this first top by itself, press enter, and then divide by -2. Alright, so do this first, then do this. Alright, on the calculator. Alright, when you do that, alright, remember your LN button, it's right next to number 4, alright, on your keypad. So when you press LN, and put this all in, you'll get 0.807. Alright, so always estimate to the nearest thousandth. Alright, so 3 places past the decimal. Alright, so those are some problems that are not too different than what we've done, just maybe a little bit more involved. Alright, using the properties that we learned last time. Alright, so number 7, you'll notice that above number 7 it says we also must start to check your answers. Alright, now if you remember when we were looking at the graph and we were talking about the characteristics of exponential and logarithmic equations and functions, we don't have any problem with anything that we plug in for x for an exponential expression. We can plug anything in for x. It can be negative, it can be positive, it can be 0. That's all fine. However, logs are restricted. Right? Their domain is not all real numbers. What we have to always make sure of, and I've done this so far, is we must check our answers to make sure that we get no negatives, right? So no negative numbers, or 0, right, inside the log. Any log. Natural log, log base 10, log base anything. Alright, no negatives or 0. Alright, if we get a number that makes our log either 0 or negative, where we're taking log of the number, and it's negative or 0, then we cannot use that as a solution. Alright, so let's see a couple examples where that might happen. Alright, so number 7, I have 2 times 8 minus 5 to the x equals 17. So again, I have to isolate my expression here, 5 to the x. So I'll start by dividing by 2. So that gives me 8 minus 5 to the x equals 17 divided by 2, 8.5. Alright, so I want to subtract 8, further isolating my exponential expression. So I get negative 5 to the x equals 8.5 minus 8, 0.5. And then I just need to get rid of that negative 1. So I have 5 to the x equals negative 0.5. So, exponential equation, just like we did in number 3 or number 6. Alright, I need to take the log of both sides using the base. Base in this case is 5. So, log base 5 of 5 to the x equals log base 5 of negative 0.5. Oh no! This is a negative inside my log. No, no, no. So, this one has no solution. No solution, right? So we didn't even get a chance to even try and see if it might work, right? No solution. Alright, no solution. So even exponential equations, because you take the inverse in order to solve it, can end up having no solution. Alright, so make sure that you are very aware that you cannot have a negative number inside the log. Alright. Now number 8, alright, looks like it might be easier for number 8. Number 8, we have log of x plus log of x minus 3 is equal to 1. Alright, so we start with logs, so maybe we'll be okay. So, my properties of logs, right? I have two logs added together, so I need to combine them into a single log. So I have log, and then I have x times x minus 3, and that equals 1. Alright, so I want to distribute that x, so that gives me log, I guess I'll use parentheses now, x times x is x squared, minus 3 times x, 3x, and that equals 1. What is my base? What is my little invisible base? Well, hopefully you said 10. Alright, so again I have base 10. Alright, so base 10. So, change to exponential equation. So I have 10 to the log of x squared minus 3x equals 10 to the 1. Alright, so 10 to the log base 10 cancels out. X squared minus 3x equals 10 to the 1, which is just 10. Now, what do we always have to do when I have a quadratic on one side and everything else over here, or something else over here? I need to move it over, set this equal to 0. Alright, so I subtract the 10. I have x squared minus 3x minus 10 equals 0. So, I have a quadratic equation which needs to be factored. I know you're just loving it. So, multiplies to get negative 10, adds to get negative 3. X minus 5, x plus 2. So I have two separate factors, so I need to set each one equal to 0. So x minus 5 equals 0. When I add the 5 over, I get x equals 5. X plus 2 equals 0. Subtract the 2 over, which gives me x equals negative 2. Now I need to check my answers. Always check my answers. So if I take x equals 5, so I stick it back into the original equation. So if I have log of 5, well, that's fine. Log of 5 minus 3, that's 2, so log of 2, that's fine also. So x equals 5 is an answer that we want. Now negative 2, log of negative 2. Nope, automatically that doesn't work. Right? We give us negative 5 here. We can't have like log of negative 5 either. Right? So this is an answer that we cannot have. And this is an example of some things that we're going to get. Right? But be careful. Right? Say we got an x equals 1 as an answer. If I stuck in 1 in for x in the second log expression here, 1 minus 3 would give me negative 2. Alright, so that would have made that 1 not work even though it's positive. Because it makes one of these logs negative. It makes one of them negative, it makes the entire problem. It doesn't work for anything. Alright, so as long as it doesn't, it can't work for one of them, if it has to work for all of them. Alright, so this x equals 5, right, is the only one that works for both logs. The negative 2 doesn't work for either one. Alright, so you just need to be really careful to make sure that you don't get a negative number inside that log and you do not get 0, because that just doesn't exist. Alright, no matter what the base. Alright, so hopefully that makes sense. Alright, so turn it over onto the back. Alright, so here we have some examples of some formulas, some of which you're familiar with. Alright, then I'm just going to go through real quick. We're going to use these in word problems that will start next class. Alright, and I'll be back then. But these are just ones that you sort of need to be aware of what's coming. Alright, so when we have half-life, growth, decay, you've heard of like radioactive decay, right? That uses half-life of the element or isotope you're dealing with. So sometimes we have a base of 1/2, sometimes a base of 2. Alright? And then, we have whatever A is out front, and then T over H, H being when a half-life occurs. Okay, so that's the H, and we'll get to that. Now the second one, this one right here, this is one that we know very well. Okay, this is formula for exponential growth or decay when we have a rate. So we had depreciation, say by 7%, or we had a population growth of 11%, or any kind of thing like that. So this is something that we know very well. This is an equation that we were making ourselves before. So this is something that we know. Now, the next two, all right, they deal with money because they're dealing with interest. Right? Either interest that you pay, say on a credit card, or an interest that a bank pays you when you have an account. So the first one is just compound interest. That means that we have interest that occurs more than once a year. So let's say you have a quarterly interest. All right, so that means that it occurs 3 times a year, every quarter of a year, or 4 times a year, but every 3 months. All right, that's where that N comes in. Right, because it looks a lot like our normal formula, right? Oh, I forgot to put the A here. That's the initial, so that's the A. And then, so this is our initial, but that N is there, right? Because T is usually number of years, how long it takes to earn a certain amount of money. But the compound interest, right? If it's, we're earning interest every 4 times a year, or bi-monthly, which is 6 times a year, that's where the N comes in, and that's why we have to use that. Continuously compound interest means that it takes interest the whole time, right? And that's where we use a base of E. All right, so the base would be E, P just stands for the principal, the initial amount, and then R is the rate, T is the time. All right, so we'll get into this a little bit more, but it's just good to be able to be aware, all right, of the formulas that we'll be using and the variables that we're solving for. All right, so I'll talk a little bit about it, but most of the time for today we're just dealing with solving equations that are in a certain form. And it's good for you to know which form they're excuse me, which form they're from. All right, so let's look at number 9. All right, so zoom in here. Whoops. Alright, so number 9, we have 100 equals 40 times 2 to the T over 3.5. So like always I want to isolate my exponential expression first. So I need to divide by 40. Alright, so 100 divided by 40, we get 2.5. And that equals 2 to the T over 3.5. Alright, so when I have an exponential expression, I need to change it to a log expression, and I need to use the base. In this case, my base, right, my number with an exponent is 2, so I take log base 2 of 2.5 equals log base 2 of 2 to the T over 3.5. Alright, so take log base 2 of both sides. On the right hand side, log base 2 of 2, going to cancel out. So I get log base 2 of 2.5, you can use parentheses or not, is equal to T over 3.5. Alright, so I just multiply by 3.5 on both sides. So 3.5 times the log base 2 of 2.5 is equal to T. Alright, when I put it in the calculator, I get T equal to 4.627. Alright, so this is a growth, alright, And t could be days, hours, months, years, any, whatever the question calls for in terms of the units of time. Alright, so we would just put this in the calculator and solve for t. Alright. So, number 10, alright, deals with a question that is going to deal with half-life, okay, decay, because this is 1/2 here. Alright, so again, I want to isolate this. Alright, so I need to divide by 700. Alright, when I do this, alright, my zeros are going to cancel out, and I'm going to use actually the fraction 1/7. Alright, because the decimal is long and drawn out, and I just don't want to have to write it. So I'm going to use the fraction 1/7. And that is going to equal 1/2 to the t over 12. Alright, so again, I have an exponential equation. I need to take the log of both sides. The log is going to be base 1/2. So I have log of 1/2 of 1/7 equals log of 1/2 to the t over 12. Alright? Log base 1/2 of 1/2. Alright? Crosses out, so I have log base 1/2 of 1/7 equals 7 t over 12. Solving for t, so I multiply by 12 on both sides. So I have 12 times log of base 1/2 of 1/7 equal to t. Alright, again, I use my log base in my math menu of my calculator, and I get t equal to 33.688 units of time. Usually years, but not always. So it depends. Alright, so 33.688. Alright, so we're doing well. We're just going to keep on going. Sorry if I didn't move that over. Alright, so moving on to number 11. Alright, so this is a formula, or this is an equation, like some of the ones that we made at the end of Unit 10. Alright, so this might represent, say, population. Alright, starting at 165,000, growing to 210. Alright, so this would be population growth. And what we need to find is we need to find the rate. It wants us to find that rate, the rate of increase. Alright, so this is going to be a little bit different. This is actually going to utilize some skills that we learned even in Unit 9. Alright, so let's work this out. Alright, so again, the 1 plus r has the exponent. So I need to divide by 165,500. Alright, when you put this in your calculator, you're going to get a big, long decimal. I'm going to write the first little bit of it. So 1.26888, and then it continues on forever. So dot, dot, dot. Alright, and that is going to be equal to, once these cross out, 1 plus r to the 15. Now, if you remember back to Unit 9, way back to Unit 9, alright, when we had an exponent that we needed to get rid of, alright, most of the time we were doing rational exponents, right, exponents with fractions. Alright, when we had to get rid of an exponent, alright, we would multiply by the reciprocal. You may remember some problems where we had a variable to the 3/2, and we had to multiply that exponent by 2/3. Alright, we have to do kind of the same thing here. So I'm going to multiply my exponent by, sorry, not t over 15, 1 over 15. So 1 over 15. Alright, that will give me an exponent of 1 on this side, because everything cancels out. Alright, so I get 1 plus r. And then when I actually put in the calculator, and I do 1.26888 forever ever to the 1/15th power, I actually get 1.016, and then it's like 002, on and on and on. Alright, so it's actually kind of nice. Not so bad. Solve for r, subtract 1, subtract 1. So I get 0.016002 dot 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 equals r. Now, if that's it for the percent, okay, if I want to find the percent, usually if I'm given the percent, I divide by 100 in order to get the decimal rate. So, in order to get the percent from the decimal, I just multiply it by 100. So, my rate, moving my decimal place over twice, is 1.6%. Right? And usually that's enough. Usually that's enough. Right? So, in this case, we found the percent using some of the things that we learned about from Unit 9, right, of multiplying by the reciprocal for the exponent, and using that power on the opposite side as well. Alright, so in this case we had to use 1/15th, and that gave us a way to find r. Alright, so just a few more. Alright, so number 12, right, again, this is something very familiar to us. Alright, so we have the initial, 1 minus the rate, alright, so this would be 11% decrease, because it's minus. And this time we are actually finding the exponent, so this makes more sense to us. Alright, so first, let's combine this. Alright, so 16 equals 145, 1 minus 0.11, 0.89 to the t. Right? And then I need to isolate it by dividing by 145. Alright, so keeping it again as a fraction because the decimal is just horrible. Alright, so I get this. So in order to solve for t, alright, I look at my base. Alright, 0.89 is my base. So again, exponential needs to be changed to log. Alright, so like all the others, I take the log of that base. So 0.89 of 16 over 145 equals the log, base 89, of 0.89 to the t. Now the right hand side becomes very neat, right? Log base 89 of 89 crosses out. So I get log base 89 of t over 145. No, 16 over 145, I'm sorry, equals the t. Sorry about that. And then when I put this in the calculator, alright, so this is my exact answer. And when I put this in the calculator, I get t equal to 18.914. Alright, so that again could be any unit of time. That could be months, days, years, decades, hours, who knows. Alright, so that could be almost anything. So, very similar to the things that we used to solve before. Alright, it's just instead of having more variables, we have just numbers and we're solving. Alright, so 18.914, whatever units of time. Okay? So number 13, we're almost done. Alright, so this is an example of when we have the compound interest. Alright, and that 4 would mean that we get it quarterly. Alright, so 4 times a year. Because t is always going to be time in years. Alright, so but again, we'll get to that. Alright, so solving for t, this sort of my base. Right, well actually let's find what the base is. Let's actually find out what this is. So 4,000 equals 12,050, or 1,250, excuse me. And then when I take 0.09 divided by 4, I get 1 plus, and then 0.0225 to the 4t. Right? So I can add this together. So I get 4,000 equals 1,250 times 1.0225 to the 4t. Alright, so my base, 1.0225. Okay, so now I just need to isolate that by dividing by 1250. Alright, so 4,000 divided by 1250 is 3.2. Alright, and that's going to equal 1.0225 to the 4t. Alright, so like my other ones, I need to change this to a log equation using this 1.0225 as my base. So, I have log of 1.0225 of 3.2 equals log of 1.0225 of 1.0225 to the 4t. Well, right side, cancels out, leave me with 4t, which is much nicer. And over here on the left hand side, I've got log point base 1.0225 of 3.2. Solve for t, I just need to divide by 4. Alright, so t equals log base 1.0225 of 3.2 divided by 4. Alright, and then t, if you take the decimal approximation, it's going to be 13.069. Alright, so t is going to be in years, so it would take a little more than 13 years. Alright, again, we'll deal with context a little later on. Alright, last one. So I have 12,000 equals 4,000 times e to the 0.03t. Alright, so this is going to be continuous compound interest. Alright, continuously compound interest. Alright, because we're going to have a base, in this case, of e. Alright, so this is going to be base e. Alright, this is the actual formula that banks use, so this is important stuff. Alright, so now I have to isolate my exponential equation by dividing 12,000 divided by 4,000, this gives me 3, e to the 0.03 t. Alright, so I have base e, I established that already. I need to take the log of both sides, but when I have e, I use a very special log, or I use natural log. So I have natural log of 3 equals a natural log of e to the 0.03 t. So natural log of e cancels out, so I have the natural log of 3 equals 0.03 t, and then divide by 0.03 to give me t. So I have the natural log of 3 divided by 0.03 is going to be equal to t. Alright, when we stick this in the calculator, alright, natural log button, again right next to the 4, alright, I get t equal to 36.620. Alright, again, that's going to be years, but we'll talk about that again a little bit later. Alright, so this is some of the equations we'll be using when we get to word problems. And these are going to be very similar to the ones that we'll use. Alright, the numbers are obviously going to be a little different. Alright, but this is going to be very similar to the problems that we'll use and the numbers that we'll use. Alright, so I would appreciate if you would pause as needed and hand out the homework. Alright, so pause please right now, and then I have something to say about the homework real quick. Alright, so hopefully all of you have the homework now. What I'd like you to do is turn on the back of the homework and look at number 10. Alright, so number 10, alright, you see in the little note I wrote over here, it says e is the variable, solve for e. Alright, so this is not base e. This has nothing to do with the e the little lowercase e that we use, all right, this e represents energy. All right, we're talking about energy of an earthquake, so this is a formula, another formula that we'll use. All right, so you're solving for e. If you need to cross out the e and put an x, that's fine, just so if you think it's going to mess you up. All right, just make sure that at the end you put e equals 2 instead of x equals 2, because e is the variable. All right, so I just wanted to make sure that you know that you need to solve for e. All right, so that is the notes for today. Hopefully that was not too confusing. I will answer any questions from the homework next class. If you need to come to tutoring, the answers will be posted online, or should be already posted online today. So hopefully, you didn't have too many questions, but I will answer some next class, which is going to be Thursday, I guess. All right, but we're going to start at word problems. This just gives you an introduction, dealing with some of the numbers, types of problems that we'll be dealing with, all right, particularly these ones on the back. All right, so you have the rest of the period, however much time that is, to work on the homework. I appreciate you guys being understanding. I hope this was not too horrible, because we might have to do this again sometime. But I will see you back on Thursday. Again, tutoring Wednesday and Thursdays, mornings and afternoons. All right, just not this afternoon because I'm at the doctor's. So you can pause it, stop it, however you want to do. Thank you very much for the sub to do this, and thank you guys for understanding. All right, so I will see you on Thursday. Bye-bye.